Here we go, week 6, part 2, dealing with the center of gravity of composite bodies. So a composite body is basically like an overall body like this that is composed of several different parts that we can find their center of gravity more easily. So for this one, it is symmetric along the x direction, so we know that the symmetry is going to fall along this line, right? But y, it's not symmetric, so we need to find y bar, the center of gravity in the y direction. And for this case, we use the same equations that we used for the calculus method in the previous video, but it's a little bit more simple in my opinion. So I start by separating this into 4 different bodies, 2 of which are the exact same. And the first thing we do is we find their area, because dA just means the area of the independent components of the overall body. So for 1, we do 3 times 1, etc. I hope you guys know how to find area. The next part we want to find is y squiggle. So y squiggle is the center of gravity of each component. So if we start from the top, center of gravity for this one would be here. Center of gravity for this one, for just looking at this rectangle here, would be halfway down the rectangle, and then halfway down here. And then we want to find the distances, obviously, from the top. And so the overall length of the rectangle is 3 inches, so halfway down is 1.5. Here, finding this one's a little bit more complicated because you have 1 inch, then you go down another 2 inches, and then you just need to figure out your overall distance here, right? So it'd be 6. And lastly, we want to find the center of gravity for this rectangle from the top. So it's 1 inch overall, halfway down is 0.5, and we just write those in. You always need to make sure that you're measuring the distance from your reference point. So my reference point is the top of this entire body. You could also do the bottom of the body, but it's more complicated to find these distances in my opinion. So lastly, we just have to do y squiggle times a, because look, we have a down here, and then we have y squiggle times a up here. So multiply those straight across, and finally you just sum them up. So you sum all of the y squiggle times a, you sum all of the areas, and you do y squiggle times a divided by a. So we do 104 divided by 31, and that tells us that the center of gravity in the y direction of this entire body is 3.35 inches from the top. Another way we could do it is, because the entire body is 11 inches, we do 11 minus 3.35, and that'll tell us that it's 7.65 inches from the bottom. So let's visualize it. So our center of gravity, we said, from the top was 3.35 inches. So we go from the top 3.35 inches down. So it'd be this line. Or if we went from the bottom, it'd be this entire distance, which is just 11 minus 3.35. So either way, you can find the center of gravity either from the top or the bottom, but you just need to make sure you're labeling the distance. Is it 3.35 from the top? Is it 3.35 from the bottom? Because if you don't label where you're referencing, you're going to lose points. Alright, so here's another example very similar to this one, or to the first one. We know that it's symmetrical in the x direction, so the center of gravity in the x would fall along this line, but it's not symmetrical in the y direction, so we have to find how far down or up is the center of gravity in the y direction. So once again, we separate it into 3 different bodies. I find the area of all the individual bodies. Then I find y squiggle from the top for every single one of the bodies, and then summation, and then do division, etc. So I got 87.97 millimeters from the top, which would be somewhere along this line. And yeah, that's how you find the center of gravity.